In this question, we take the point 5, negative 3, 6 and reflect it in a line with the given equation, and we want to determine the coordinates of the image point. Well, we know that the vector from P to A is perpendicular to the line. In other words, the vector from P to A is perpendicular to the direction vector of the line. So, the good news is we know the coordinates of point A, we just happen to know them in parametric form. The x-coordinate is 2 plus 3t, the y-coordinate is negative 1 minus t, and the z-coordinate is 4 minus 2t. Now, if we journey from P to A, that's like going, the x is 2 plus 3t minus 5, the y is negative 1 minus t minus negative 3, and the z is 4 minus 2t minus 6. In other words, the vector PA is 3t minus 3, comma, negative t plus 2, comma, negative 2t minus 2. Now, that vector, when dotted with the direction vector of the line, will give 0. So we write this vector dotted with the direction vector of the line, and we know that we're going to get an answer of 0. Well, using the component method, 3 times 3t minus 3 plus negative 1 times negative t plus 2 plus negative 2 times negative 2t minus 2 equals 0. Well, that means 14t equals 7, which means that t equals 1/2. Therefore, we now know the coordinates of the point A. We can sub in 1/2 for t and determine that the coordinates of point A are 7/2, comma, negative 3/2, comma, 3. Now, we know that the vector AP is equal to the vector P prime A. Well, since we know that the since we know now the coordinates of the point A are 7/2, negative 3/2, and 3, we can sub that in and use those instead of this expression. We don't know what the coordinates of P prime are, but for now we'll call them x, y, and z. And since the vector from A to P equals the vector from P prime to A, we can say that 5 minus 7/2, comma, negative 3 minus negative 3/2, comma, 6 minus 3 equals 7/2 minus x, negative 3/2 minus y, and 3 minus z. Okay, well now what that means is that 3/2 equals 7/2 minus x. And simplifying that, solving for x means x equals 2. We also know that negative 3 plus 3/2, or in other words negative 3/2, is equal to negative 3/2 minus y. Well, if negative 3/2 equals negative 3/2 minus y, that implies y equals 0. Great. Finally, we know that 6 minus 3, which equals 3, is equal to 3 minus z. Well, if 3 is equal to 3 minus z, that implies that z equals 0. So the coordinates of the image point P prime are 2, 0, 0.